Hi, I'm Henrique Mendes, and this is CoMap, an automated soil penetrometer. It maps soil compaction data automatically, reducing human error and providing consistent data for agricultural surveying. Here's how it works. A 24-volt motor with lead screws drive the downward movement. The force is measured with a 100 kilo load cell, and the depth is measured with a magnetic encoder with millimeter level precision. The entire system is controlled with an ESP32, and it is georeferenced with a Neo 6M GPS module.
Let's run a measurement cycle. For this, the operator must get on top of the equipment and press the start button, the green one. The device will drive the stainless steel rod into the soil and measure how much force was needed. In the end of the measurement, it will get back to the starting position automatically. Once the measuring ended, the operator must go to the next measuring position and repeat the process. Once you have finished taking your measurements, get your physical penetrometer next to a computer and connect to it using a USB Type-C cable, connecting one end to the computer and the other end to the controller board, the ESP32. Now it's time to use the CoMap desktop application for the data analysis. This is the CoMap desktop application. The interface is divided into two main areas: the left sidebar, which handles device connection and data import, and the main panel on the right, which displays the analysis. Once you have connected your physical penetrometer to your computer, you must use the left sidebar in the connection panel. The connection panel lets you connect the penetrometer via USB. If the device does not appear here, click the refresh button to list all available ports. Then select the correct port. It should say something like ESP32. Then click Connect. Once connected, the status indicator turns green. Below the connection controls, there are two additional actions: to transfer data, to download the penetration records stored on the device, and wipe SD card to clear the card after a successful transfer. As data flows in from the device, the live console will expand automatically and show the serial output line by line, useful for confirming the device is working correctly. You can collapse it at any time if you want to save some space. Let's import some data. Click Download Data. The live console shows it being downloaded, and then the main panel shows the analysis. Once data is loaded, the main panel shows the compaction profile for each penetration. This chart plots cone index in megapascal or MPa on the horizontal axis against depth in millimeters on the vertical axis. So you can immediately see at which depth the soil becomes harder. If you want to see specific penetration, you may want to click Show Penetration Markers on Map and pick which penetration you want to see. Let's say I want this one. Click it. The graph adapts automatically. You can use a depth filter slider above all the charts to limit the view to a specific depth range. Let's say I want to view full depth. Then the chart adapts and shows up to the maximum depth measured. For this measurement, the peak compaction happened at around 22.7 centimeters deep, with this count index 2.716 megapascal. The interface also shows 3 fuel heat maps side by side, one for each depth layer. The left one for topsoil from 0 to 15 centimeters deep, the middle one from 15 to 30 centimeters deep, and the rightmost one showing the maximum depth measurements that are more than 30 centimeters deep. All of the 3 maps are synchronized. If you pan or zoom one of the maps, it will reflect in the other ones. You can also export a PDF report on the data that was measured. For this, click Export PDF Report. Here, you can pick your file name and location to save this file. Here, I'll save in my home folder. Let's see the PDF report. In my home folder, report.pdf. This is our report. The report includes the field summary table with average and peak compaction per layer, risk classifications, some agronomic recommendations, the fuel heat maps, and a critical profile chart for the worst case penetration, the highest cone index, the most compact point. That covers the main functionality of CoMap.